Good morning. Today is going to be lesson 4.6, which is all about atmospheric pressure. Now, when we think of pressure, we might think about it in a social situation, or maybe we think about it as the feeling we have when someone pushes us, makes contact with us, or something like that. However, what we want to think about today is the pressure caused by everything that's going on above us. So the atmosphere that's above us is actually going to be constantly pushing down and down and down and down on us. And so what I've drawn here is actually just like a fake mountain, if you will, to show that the longer the arrow that I have, the more atmosphere I actually have pressing down on a given area. So our first idea or characteristic of atmospheric pressure is going to be the altitude. So as your altitude increases, goes up, so we're higher up, then your atmospheric pressure will decrease. There's less atmosphere, less gas pushing down on this point than there would be compared to the next point. So now we see as altitude decreases or it goes down that the atmospheric pressure will increase. There's a special name for what this is. It's called an inverse relationship. And what an inverse relationship tells us is as one variable makes a specific direction, so it goes up, it goes down, increases, decreases, that the other does the exact opposite. So in our case, our first variable is altitude, and our second variable is going to be atmospheric pressure. Our second is humidity, and if you remember from our previous lessons, humidity is the amount of water that is trapped within the air and the atmosphere. So as humidity increases, pressure decreases. As humidity decreases, pressure increases, which might seem a little bit odd because you're thinking, all right, there's more water in the atmosphere, which means that more water is going to push down on us, which means we're going to have higher atmospheric pressure. Except that the water vapor that we would find in very humid air actually weighs less than the gas that would otherwise be there. So by increasing the amount of water through humidity, you're decreasing the amount of other gases, and therefore the higher the humidity, the lower the atmospheric pressure. So here in North Carolina, on a summer day, it's about 105. High humidity, we're going to see that we have much less pressure on those days than we do on others. That idea also leads us perfectly into our last characteristic, which is temperature. So as temperature increases, you're going to see the same change in pressure because as the air is heated, it expands and it gets bigger and bigger and bigger. I mean, there's less molecules per area that are going to push down. So if you have less molecules pushing down on something, it's going to not feel as much pressure. So increases in temperature spread out the air, lead to it decreases in atmospheric pressure. Now, one of the reasons that this pressure is so important is because it helps create winds on the Earth's surface. So everything's going to move low to high pressure. And when it does that, it's going to go from high to low pressure. When our air masses go from high to low pressure, that movement of mass of gas is going to cause wind. So the greater the difference between the air pressures, say that air pressure 1 is 100 and air pressure 2 is 2, then we're going to find that it's a 1 to 100 strength or 100 times as strong because we have so much of pressure but not enough to change that. So higher pressure will mean a higher. So the last thing, as I pace back and forth, I want to talk about is just wrapping things up. So as I said, higher air pressure means that it's going to want to go towards an area of lower pressure. When this high air pressure goes to lower pressure, it's going to cause wind. It's going to cause a breeze because something's getting displaced, and usually that's going to be the gas.